There's a place on Earth where the rules of biology seem completely flipped, where sea spiders grow as wide as dinner tables, jellyfish stretch longer than whales, and plankton look like something out of a microscope horror film. It sounds like science fiction, but it's not. These giants live under the ice in the most remote, frozen parts of the planet. And what's even more bizarre is this. They didn't become massive in spite of the cold. They became massive because of it. It's a phenomenon scientists call polar gigantism, and it's one of nature's most mind-bending tricks. In the icy waters around Antarctica, evolution doesn't shrink things down to help them survive. Instead, it supersizes them. While warm oceans are full of sleek, fast-moving creatures built for competition, the cold, stable waters of the South are a breeding ground for slow-moving titans. These animals aren't just bigger than their relatives, they're unrecognizable. One of the most famous examples is the colossal squid, a creature so elusive and massive that it borders on mythical. But what's often misunderstood is that its size isn't just due to living deep underwater, it's due to the environment. Unlike the more well-known giant squid, which lives in various parts of the deep sea, the colossal squid is practically a citizen of Antarctica's frigid oceans. It's here, in water hovering near the freezing point, that it evolved to be not just large, but massive enough to rival some whales in weight. The secret? Oxygen. Cold water can hold a much higher concentration of dissolved oxygen than warm water. And when you're an animal that relies on pulling oxygen directly from your environment, like squids, sea spiders, or jellyfish, that difference is game-changing. Higher oxygen levels remove a major limitation on body size. Over time, evolution doesn't just allow bigger animals, it favors them. And that's only the beginning. Take a look at the Antarctic sea spider. Its tropical cousins barely stretch a few centimeters. But in the polar south, these creatures grow to terrifying proportions, some nearly 2 feet across. And these aren't muscular, armored beasts like crabs or lobsters. They're slow, delicate-looking predators that stalk the seafloor with legs so long they resemble stilts. They absorb oxygen directly through their legs, and in these oxygen-rich waters, that system becomes absurdly efficient. The more leg surface, the more oxygen, and the more oxygen, the bigger they grow. And it's not just size. Behavior changes too. These giant sea spiders don't just bumble around, they actively hunt. Using a long, flexible mouthpiece, they pierce soft-bodied creatures like sponges or starfish and suck out the insides like a milkshake. The starfish, by the way, are just as monstrous. In Antarctica, they don't stop at 5 arms. Some have over 50, giving them the ability to overpower prey and even fight other starfish for dominance. Another freak of the deep is the lion's mane jellyfish, an animal so long it outmeasures the blue whale. While tropical jellies tend to stay small, this species thrives in polar waters. Its tentacles can stretch well over 100 feet, drifting silently through the water like some ancient leviathan. Meanwhile, its warm water relatives remain short and compact. The difference again? Cold water, oxygen, and time. But what makes these cold water habitats so perfect for giants isn't just the oxygen. It's also the temperature stability. In warmer environments, animals are constantly adapting to seasonal swings, predators, and sudden environmental changes. But the deep Antarctic is consistent. The water is always cold, food arrives seasonally but predictably, and the ecosystem doesn't change much. Over millions of years, this has created the perfect conditions for slow but powerful evolutionary changes. The kind that lead to enormous creatures built for patience and efficiency rather than speed. Another key reason why animals grow so large here is metabolism. Colder temperatures slow everything down. Digestion, growth, even movement all happen at a slower pace. But instead of being a disadvantage, this turns into a benefit. Larger animals burn less energy per unit of body mass. They can survive longer on less food, store more energy, and move with careful, calculated precision. In a place where food might only be available a few months out of the year, that's not just smart, it's essential. Now, you might wonder, Why don't we see this with polar bears or emperor penguins? They're big, sure, but not monster of the deep, big. That's because polar gigantism only works for cold-blooded animals. Creatures like squids, jellyfish, and sea spiders don't generate their own heat. They don't have to burn calories to stay warm. So when the water gets colder and oxygen levels rise, they thrive. But warm-blooded animals like bears or birds are limited by how much food they need to stay alive. Bigger bodies mean more calories burned, and in the polar regions there just isn't enough food to sustain something the size of a bus. That said, warm-blooded animals do get bigger in cold places. This is explained by Bergmann's rule, which states that animals in colder climates tend to have larger bodies to help retain heat. It's why a polar bear is bulkier than a black bear, and why emperor penguins dwarf tropical birds. But there's a ceiling to how big they can get, one that cold-blooded animals in the ocean simply don't have. Interestingly, the opposite of gigantism also happens in polar oceans, though it's rare. Some fish species, like certain ice fish or snailfish, have actually evolved to become smaller. This is due to a different strategy: polar dwarfism. In ecosystems where food is extremely limited, shrinking down helps these animals reproduce faster and survive longer stretches of scarcity. A smaller body requires less energy, which makes a huge difference in a place where food isn't guaranteed year-round. What makes all of this even more fascinating, and a little eerie, is that evolution down here moves in slow motion. Because of the cold, some of these creatures take decades to reach reproductive maturity. That means a single generation might span 30 or 40 years. As a result, many species have remained virtually unchanged for millions of years. Some sea spiders and urchins alive today look almost identical to fossil records from a time long before humans even existed. They are, quite literally, living relics of an ancient ocean. But there's a downside to all this stability. It's fragile. The same environmental conditions that allowed these animals to evolve into giants are now being threatened. As the planet warms and ocean temperatures rise, even by a few degrees, the entire system begins to unravel. Warmer water holds less oxygen. Metabolisms speed up. That slow, energy-efficient lifestyle becomes unsustainable. And suddenly, size becomes a burden. Recent studies show that in some warming regions of the Antarctic, sea spiders are actually getting smaller. The fear is that animals like the colossal squid may face similar fates, or vanish altogether. Creatures that once ruled the deep because of the cold may not survive without it. And because they evolve so slowly, they can't adapt in time. It's a strange thought that the world's most monstrous sea creatures, evolved to perfection over millions of years, might disappear, not because of predators or extinction events, but because the cold is disappearing, and with it, the giants it created.